Hello everybody and welcome back again to another video tutorial of Roy's Academy. In this video tutorial I am going to discuss a very important and very exceptional topic on the concept of the cornflakes processing. Okay, so there are basically two types of cornflakes processing. Okay, the cornflakes that has been the most common ready to eat or ready to cook food products or ready to serve food products out and available out in the market, and most hygienic and staple food products since years, okay, since last 2 decades or might be more than that. Cornflakes somehow globally, I am speaking, globally it has been popular as one of the uh, uh, instant heavy food, okay, or instant calorific food, energy giving food. Okay, it can be consumed by the babies, by the toddlers, by the youth, by the adults, by the senior adults or senior age persons, or even they're being served in a very weaning, like baby food or weaning food preparation in that weaning style recipe for the patients. Okay, for the patients who have lost the functionality of their facial muscles or the peristaltic muscles, the liquid foods that are being given, the cornflakes have been provided to them. So cornflakes, whatever it is, whatsoever, has been the one of the most easiest type of food, or the convenient type of food, or particularly convenient food, I must say, which has hit the market globally on a very large scale. Okay, being itself an expanded kind of food product or an expanded product, it has expanded itself all over globally. Okay, so cornflakes has been one of the most convenient and one of the most calorie giving, energy giving, and easiest consuming, time effective or cost effective consumption, cost effectively consuming food product all over the market out here. Now, this cornflakes is being processed in industries in two different ways. One is the conventional processing, and that is very much lengthy. Okay, and another is the extrusion processing. Now, both of these two processings are having different means. I will explain the concept or the science behind adopting these two types of processing in my course of explanation. The first one, what we need to look, or what we need to have the focus on, is the conventional processing. Okay, so in case of conventional method of processing, the first step that comes in our mind, the first step that happens in the industry, and the first step that comes in our mind is before any kind of processing, we need to have the purification of the product. Okay, the sorting and grading. Now, after the sorting and grading is being done, whatever it is, the best of the best, or the best hygienic product, or the hygienic raw material that has been procured, the maize has been procured, and those have underwent the milling process, the dry milling or the wet milling, whatever it is, it has underwent. Now after that, in the cornflakes processing section, size classification purification is being done. That is the first step that comes in our mind, that how the size is being separated in case of both the processing. That is, in order to have the cornflakes, it is not that one corn is being the maize is having two innumerable number of corns, right? Hundreds and hundreds of corns. The one corn is being converted into the cornflakes. It is not like that always. There are different means of processing it in order to convert it into a cornflakes kind of appearance. Okay, so when you eat the cornflakes, you are having that smooth, buttery and chips kind of texture, very brittle, very sophisticated texture. How it's happening. Here's how what the process what the process is adopted by the industries is, what is done behind the screen. Okay, out from the reach of the common public. Okay, or the civilians. The first step is the size classification purification. Size classification. Now, in this size classification step, the size of the corn grits that are being taken in this particular step are only about 3 to 5 millimeter. 3 to 5 millimeter. Okay, the grit is nothing but, we have a corn kernel right here. Suppose this is a corn kernel, okay, and now this is the this part is the cotyledonous part, okay, here cotyledonous part, this is the kernel or the germ layer, and this is the endosperm. And this part here is actually the innermost section, the germ section, okay, the germinal section or the germ. So let us write germ, okay, the innermost part, the middlemost part. Here the endosperm is the most nutritious part present here, and this entire portion is the germinal part, and among this, within this germ, there is another structure present here in the corn. This part is called the hilum, okay, hilum section, hilum. Okay, this is what a rough diagram of a corn is. Corn. Now, what is the grit? Corn grit. What is the grit? Grit is nothing but this removing the cotyledon right up from this diagram. If I remove right up from this endosperm portion, having the germ, entire germ. This germ is nothing but this particular area which is present within the endosperm, and along with the endosperm, it is forming the germ, and this is the hilum portion, the middle portion of the corn, and removing the kernel, we are getting what? The endosperm, the germ, and the hilum. Okay. Now the germ and the grit. Okay, germ processing and grit processing. Now what happens is, during the course of milling, dry milling or wet milling, this germ section along with the hilum, is totally removed. Okay, this part is totally removed. So only the endosperm part is present. Now this endosperm part is called grit. Actually the endosperm part is actually the grit. The germ part is nothing but the innermost part that was present here, that I drew here. This innermost part was the germ, and the hilum was nothing but the fissure, the groove that is present within the germ is called the hilum, and endosperm is nothing but this nutritious part which is present, is perforated. This dotted area is actually the endosperm, which is the most nutritious part within a maize corn. Okay. Now removal of the germ would give rise to what? The grit part. We are removing the kernel and we are removing the germ. Germ is nothing but the innermost hard portion of the corn that is present, and the germinal layer or the germinal covering is nothing but the kernel covering that is present. So we are removing the kernel part and the germinal part, the germinal covering or the layer, and we are taking the grit. Grit is nothing but this, and only the endosperm section. Now after we remove this, we are having the grit. In the dry milling or the wet milling section, we are having the grit. Now after the grit is being achieved, okay. Now after the grit is being achieved, that grit is being milled into separate sizes and shapes as per the requisite product. Now that grit is being undergone through the size classification. That grit is subjected for the size classification. So here the 3 to 5 millimeter diameter is not, the average diameter is nothing but that of the grit. The germ is nothing but from where the germination is happening. Okay, within the corn seed, each maize seed or each maize. Okay, now the kernel is nothing but the outermost layer, and the germinal layers are nothing but the innermost germinal layer, then the outermost germinal layer, the ectoderm, the endoderm, okay, and the endosperm, all these things. Now the endosperm is nothing but the endodermis, and the ectoderm is nothing but the kernel, and the germ from where the actual germination was happening was the innermost section, which is having the groove, the major groove, or a fissure-like appearance, which is nothing but the hilum of the entire maize grid. Now, if we remove the kernel and if we size or if we temper the corn grid, the entire corn structure, we will get the grid section devoid of the germinal section, the innermost germinal section, and the hilum devoid of that. We will get only the endosperm part. Now in the endosperm part, if the endosperm part is being again resized, again it is being tempered, we can achieve the size classification of 3 to 5 millimeter. So that is nothing but this classification of the size is nothing but the grid. Okay. Now after the size classification, the grids are being agitated in a cooker. Okay. Agitated steam cooker. Now in this agitated steam cooker, what do we have? This agitated steam cooker is nothing but where all the grids are being incorporated, and through the sparging of the air, with the help of air or bubbling up, the grids are being heated and vigorously agitated. That is, it is being tossed and tumbled in different directions within that cooker, also in the presence of high pressure. Now the time taken for this purpose is 3 hours. The temperature is about 100 degrees Celsius, and the moisture content here is about 34%. Okay. Now after this agitation is being done, agitation is generally done in order to soften the endosperm. Or even how if the germinal portions are present or the hilum portion is present, in order to soften the endosperm, in order to release the nutrients, the vitamins present within this endosperm part of the corn grid. Okay, in order to do that, this particular step is being done. And after this agitated steam cooker, the corn grids are subjected for venting and cooling. Okay. Venting and cooling, which is being done or achieved to a temperature of about 100. It was previously in agitation, it was 100. Now the cooling is done at about 70 degrees Celsius, or it might be little bit less, let's say about 50 degrees Celsius. The cooling is being done, because the cooling is very much necessary, because if the cooling is not done, if somehow after the agitation the corn grids are having that much of heat content, okay, latent, that much of heat content latent or hidden within this entire broth or entire culture of the entire volume of the corn grids that are being incorporated within the cooker, then in that case what happened? The functional compounds that are present in the corn grid would get degraded, and the vitamins, some of the proximate compounds of food would get degraded. But we don't want that, because that would produce a very undesirable palatability. Right? Now, so after venting and cooling, what's done is lump breaking. Lump breaking means during cooling what will happen? The corn grids will adhere with each other due to the presence of little bit of moisture content among themselves. So lump breaking is very much necessary before subjecting it to drying. Now after that, after the lump breaking is being achieved or done, belt drying is being subjected. Belt drying. Okay. All the corn grits are being flattened over or distributed over a belt, a conveyor belt. Okay. Belt drying. Where the belt drying is done for about only 10 minutes and at a moisture content of 21%. The moisture content is 21% and the time is 10 minutes. Only for 10 minutes time interval or that specific window of time, this belt drying is being done in order to remove the excess moisture. From 34 it is coming to 21%. And after belt drying, it is subjected to tempering. Okay. Tempering means beating the corn grits in order to reduce the size. It's actually a size reduction step in order to reduce the size more. That's why the tempering is being done. Now, during the course of tempering, the belt drying. The belt conveyor is subjecting the dried corn grits to the tempering section, where continuous hammer beating or tempering is being done in order to reduce the corn grits. And after the tempering is done for about 2 hours. 2 hours, and that too at a subsequent temperature of 80 degrees Celsius. 80 degrees Celsius with 18% moisture. With 18%, only 18%. So see, from 21 it is coming to 18% after the drying. Okay, so about 3% moisture is getting reduced in the sensation. So this is achieved in 2 hours for the entire volume or the entire batch capacity of the corn grits that are being subjected for this particular purpose. And at 80 degrees Celsius it is being done so that the moisture content is also getting reduced. Now after tempering, directly after tempering, it is being subjected to flaking. Flaking means where with the help of pressure, the corn grits which have got mixed with each other, or the lump which has been broken, the corn grits which has become soft and soggy now are being flaked at high pressure with the help of a machine where the grits are being smashed. Whether it would be the grits, now 3 to 3 millimeter grits or the 5 millimeter grits, they are being smashed. So in this case, what happens? The grits are singularly smashed. In this particular process, conventional way of processing, each of the grits are getting smashed. Okay, so flaking is coming here in this section. Flaking is achieved at very high temperature, very high pressure. Okay, along with a very high temperature, where each of the corn grits are getting smashed, totally smashed, and having that very brittle, sophisticated, thin appearance that we are having in the cornflakes. Okay, that is fine. Flaking is nothing but the final formation or final shaping out of the cornflakes from the corn grits. And after flaking comes the process of toasting. Toasting at 3 degrees Celsius. Sorry, not 3 degrees Celsius, it's 3% moisture. Toasting at 3% moisture. Now, after the toasting at 3% moisture comes the process of, or the step of what? After toasting at 3% moisture comes the step of what? Toasting at 3% moisture means it's if the toasting is not done after flaking, it is having about 18% moisture, right? So toasting is done in order to remove the sogginess as well as in order to remove the stickiness among the flakes. That is why the toasting is done. So see, from the 34% moisture, it's coming to 3% only, right? After that, enrobing is being done. Enrobing means coating the cornflakes, coating the flakes, each of the flakes, okay, with a desired kind of condiment or a desired kind of concoction. That might be a set of additives, or that might be a set of other nutritious substances, or that might be a set of a different kind of food. As for example, we have composite chocolates like wafers and all. Okay, pork and all. Porks are composite chocolates. Those are being enrobed. Enrobed means those are coated with the chocolate sauce. Now, in this case also, in case of the chocolate flavored cornflakes, the pineapple flavored cornflakes and all, enrobing is done. The kesar badam flavored cornflakes and all, whatever it is. Then peanut butter flavored cornflakes, in strawberry flavored cornflakes, Kellogg's cornflakes that are out in the market. Enrobing is done with that particular texture of that particular fruit. Okay, that is what enrobing is. And after enrobing comes the process of cooling. After enrobing comes the process of cooling, because if enrobing also needs very high temperature, and if that high temperature is directly subjected to packaging, then it would damage the product. Okay, so it will not only turn the product in a very unpalatable form within the packet, but also damage the shelf life of the product. So cooling is very much necessary in order to make the product dry subsequently. Now after cooling comes the process of final step of packaging. Okay, finally comes the step of packaging. Now, this is what about conventional. This is how the conventional method of cornflakes processing is happening in the industries, behind the reach of our eyes, or behind the understanding of common people, the public and civilians and all. Okay, so whatever it is, that doesn't matter anyway in this case. So thing is the science behind how all these expanded or delicious food products are out in the market. So this is how one of the methods, one of the two methods that are being adopted by the industries behind the behind the acknowledgement of the people, or out of the reach from the imagination of the people, that how entire corn is being converted into a cornflakes. Okay, so much of processing and scientific orientation is present behind the desk, okay, in order to make the things robust as well as heuristic at the same time. Now let us have a look. What is the extruder method of cornflakes processing? Okay, this is what the conventional method is. This method is number 1. And now we have number 2, extrusion or extruder method. Now in extruder method, the first step that comes here in this case is premix. pre-mixing of the ingredients. Okay, pre-mix means here the corn grits that are being 3 to 5 millimeter in size, these corn grits are mixed with the desired kind of flavors and all, the desired kind of additives and all, the desired kind of edible coatings and all, or consistencies and all. So these are being pre-mixed. Okay, the corn grits are being pre-mixed, and after that, after pre-mixing, the corn grits are directly subjected within the extrusion chamber. Okay, so after the pre-mixing is happening, the corn grits are directly subjected to the extrusion chamber, and in the extrusion chamber what happens is extrusion, within the extrusion chamber what happens is cooking is happening. This cooking is happening at what is the time and temperature of the cooking happening? This cooking is happening at about 150 degrees Celsius only for 1 minute. 1 minute. 150 degrees Celsius only for 1 minute, with almost the moisture content equivalent, 34% moisture. Okay, now the thing is this 150 degrees Celsius, why this so much high temperature is being achieved? Because we know that within the extrusion machine the kneading shading is happening, and obviously the pressure also increases and the temperature rises to about 150 degrees Celsius. And now at this temperature what happens is all the premix gets melts and plasticized. Okay, and all the nutrients, the vitamins, functional compounds and all nutrients and all, the proteins, carbohydrates, fats, whatever it is present within the endosperm of the corn grits, the endosperm portion gets refurnished or refurbished in order to have that alternate consistency or desired texture of the final end product. Okay, now after cooking, the step that comes is cooling. Okay, after cooking the steps that comes is after cooking the steps that is incorporated is vacuum or vacuuming. In vacuuming what is done is the moisture content is reduced to about 18%. Okay, now after the vacuum, by the reduction of pressure, the moisture content is being removed, and after vacuuming what is done? Cooling is done. In this step only, after vacuuming, cooling is coming. The cooling is done at about 95, from 150 to 95 degrees Celsius. The cooling is being achieved. 150 to 95 degrees Celsius, the cooling is being achieved. And now after cooling, the step that is coming here, cooling is achieved 95 degrees. Now pelletizing. Okay, pelletizing is the next step. Pelletizing means here in this process of in this extrusion methodology, pelletizing. In this extrusion methodology, pelletizing is done for 3 to 5 millimeter. In this, okay. So now in this extrusion methodology, we can see that pre-mixing is being done. In this pre-mixing, then after pre-mixing, cooling is being done. After cooling, which is achieved for 150 degrees Celsius at 34%, same percent of moisture, and 1 minute. Only that 1 minute the cooking is being done, because more than 1 minute is being given, the functional compounds or the proteins and all would get denatured or get degraded. That would produce a very off flavor. Okay, and too much, the product would be too much stale in appearance. So the reformation of the flake kind of appearance or refurnishing would not be achieved or not be possible. Because in the vacuum section, the removal of the moisture would not be possible, because the product would be too much slurry and sludge kind of consistency. It would be happening. It would be acquiring. Also, the limitation of 1 minute, 1 to 2 minutes max to max is being achieved for this particular purpose. Now the vacuuming is being done where 18% moisture is being achieved, and then cooling 95%. 95 degrees Celsius, from 150 to 95 degrees Celsius, where cooling is necessary in order to preserve the functional compounds and nutrients and vitamins and all the cyclic structures or the ring string structure, the chemical compounds and all. And after cooling, the pelletizing is being done. So when a cooled product is being achieved, it is automatically becoming hard. And now when the pelletizing is done, the cooled product is subsequently tempered or hammered down to achieve this 3 to 5 millimeter diameter averagely, like that of what was happening in the size classification. So the major step is, in the case of size classification, already the 3 to 5 millimeter grids were being taken, and in this case the grids were being pre-processed. So the extrusion chamber, it is being processed, cooked and all, whatever it is, the entire concoction of the entire concoction of all the maize grids are being achieved, the entire concoction is being made already. And after making the entire concoction, the final step after the extrusion is being done, in the post processing step, then the pelletizing is being done of the mature or the adult corn grids. The corn grids are broken down and tempered to 3 to 5 millimeter. Now after the pelletizing, once the pelletizing process is being completed, from here it would come to the flaking process. Then flaking is being done, toasting at 3% moisture up to 3%, then enrobing is being done, cooling is being done, and finally packaging is being achieved. So this is how the extruder machine. Now the thing is, this process is kind of lengthy compared to this. Okay, and the difference is the costing in this process is little bit higher, because in every batch capacity, with every batch operation, the size classification needs to be done obviously, and the agitated cooling, agitated steam cooker operation, then venting and cooling, then belt drying. So it is taking too much of equipment or too much of inventory installations. But in this step, only through one process we are able to achieve the desired consistency of the product, the desired qualitative aspect of the product, and after that, in order to have the mechanical properties of the product, we are achieving the rheological properties. The rheological properties which were happening in all these steps, that is being achieved in only one step, that is cooking. And after that, vacuuming and cooling are the post processing. So in this one step of cooking, we are achieving the outcome of all these steps of the desired rheology of the product. And after achieving the desired rheology, we are giving the desired mechanical dimensions, mechanical properties for undergoing the packaging portion. Okay, so this is what the major difference between the conventional cornflakes process and the extruded oriented cornflakes processing is all about. Okay. Okay. So yes. So this is what this is how the differences are being made or achieved in the industry, the conventional and the extruded processing. Okay. So if you like this video, subscribe my channel positively and share this video as much as possible. Comment down in the comment section below and hit a thumbs up button. Thank you.